I should rename the brackets.
Share the screen again.
Share the screen again.
Check.
Right. Do you need mic or it's not required for you? But it can be loud here, but
It's better if you have.
Alright, good evening everyone. So we get started. Ashok, can you go to start? Alright, so my name is Prakash. I work in ThoughtWorks. I've been a developer, trainer, architect, I kind of play different roles here. So today's topic is going to be all about Git. I think most of you would be familiar with Git. The focus is not going to be on how to use Git. I'm hoping that most of you would have used Git. It's mostly on Git internals, essentially how Git works, how is it, Git being able to be so efficient, especially for distributed development, how is it efficient, things like that, right? But just to ensure that we're on the same baseline, I will just skip through some of the Git basics, version control basics, so we kind of know what we're talking, right? I think it's kind of pretty obvious what's a version control system, so I'll let you kind of read this one. All of us know this, I hope, right? If any of us here don't have good context of version control system, probably next 1 hour you can probably switch off yourself. Local VCS, again, this is almost like just a historical perspective, right? There was a system called RCS, which developers could use in their own local development machines. How do you, if you don't have any software, right? How do you do manage version control? Like you will have a let's say you have a Java file, you are going to modify that. So before you modify, you have to take a backup of that. Then you can have modify. So the one you modified becomes version 2. Again you modify that becomes version 3 and so on, right? So there is a software that could manage that. Of course, as with everything, right? So you all these innovations started with a small scale. It was started with having a version control system local machines, local developer machine. So where developers could run the software locally, check out, check in, all of that was possible. I don't think I have not started at this time. Probably not. I'm hoping some of you have, many of you have not started at this time. This setting most of us would have used in some form or the other. Subversion is a good example of this. Series is a good example of it. Force is a good example of it. This is actually literally when you had teams working together, like multiple developers working together. How do they collaborate with each other, right? So this is actually it started in CVS, then you had Subversion and Force. You had a central VCS server running somewhere in some central server. Each developer would check out this code base. The developer would have a particular version of the file in his or her machine. Whenever they modify something, then they will check in. Again, check-in process might involve some locking or not locking, depending on the version control system you are talking about, right? People who are done with TFS know there's this horrible locking that you have to do. You get the lock or a file, then you can check in, you can modify and all. Without lock, you can't do those things, right? It's almost like 20 years ago kind of situation, right? What are the problems with it? As with any central, like a master doing something, it's a single point of failure. If the server is down, what happens? Obviously, nobody can collaborate with each other. Likewise, what happens if there's a hardware failure? Again, unless there's a proper ops person taking backup, you cannot lose the changes, right? So there are, and if you had to do some git diff, for example, right? Sorry, not git diff between two versions of the file. The diff can happen only if the request goes to the server and comes back with a particular version, because all the versions are stored in the central version control, right? And then came all the distributed version control systems. Gate, Mercurial, I think there are two other software which follow this model. Essentially, what is there in server is there in every developer and quality analyst, everyone's machine as well, right? So server has like 3 versions of a particular file. The developer machines also had the same 3 versions of a particular file. Unless, of course, developer might have more changes locally, but whatever is there in the server, most likely will be in the developer's machines as well, right? So what's the benefit of it with this approach? Any of these boxes here can act as a server. There's nothing preventing it. Of course, in real world, you won't suddenly make somebody's laptop as a server. But I'm just saying, theoretically, you can make anybody's laptop as a server as well. Secondly, there's no single point of failure. If you want to do any Git operations, like for example, Git diff, you want to do diff between two versions, version 2 and version 3. It does not involve any network trip. There's no network round trip because you have all the versions in your machine, right? So distributed DCS obviously if somebody is not using distributed DCS, you can say probably they're like 10 years backward. Why would you not have that option when you have that power with you, right? Out of the distributed options, I think Git and Mercurial are relatively popular options, and even within these two options, I think Git is much more popular, right? So today, what we are going to talk about is all about Git. So when you talk about Git, so what does it involve? I'll just kind of quickly do a small, exercise just to ensure that we're all on the same page. So what I will do is just do something called GeekNight. Let's say GeekNight with a name called demo. So we have got a repo called demo. We created a demo. and it has created something called index.html. I mean, you can ignore it for all practical purposes. I'll just remove that as well so that it doesn't confuse us. So this is our working directory. Essentially, this is actually where I want to do my work. So maybe what can be the work? I can just create my maybe demo.java, right? I can just write my code here. My code goes here. Right? This is my working directory. And what's the staging area? When you develop an application, we will take it to production, right? And before you take it to production, you will deploy it to a server called staging. I mean, that's traditionally followed. The idea is that you want to kind of confirm everything is fine before you take it to production, right? It's almost similar concept. Where we got a file, which is demo.java. So what I want to do, I want to commit this file to Git. Commit is basically checking it, right? So I want to commit this file. So how I can commit? So I can just add this file. Essentially, I am telling Git, please start tracking this file. Until now, Git is not aware of this file. So if I say git demo.java, Git will say untracked file. Because Git does not know about this, right? So if I say git add this file, I told Git please start tracking it, right? But I still not checked in. What do I mean by that? Remember I was drawing the analogy of staging. When you have an application, it is in your local, it's like working directory is like having in your development machine. Deploying to staging and now it is like a staging where you want to confirm everything is right before you take it to production. So it's not exactly the same, but you get the point, right? You kind of stage it before you check in. So in the staging you can again do git dev, or you can add multiple files to staging. That's the concept of how it works. So if you do git status, now it will say changes to be committed. It's not saying untracked anymore, right? It can be committed. So now if I commit first grade Java app. Now I have committed. So when I have committed, it has gone to Git directory or Git repository. So this is just a simple three-step thing, right? We'll go deeper into this when we go into Git internals. I just wanted to highlight these things. Essentially, you've got a Git repo, you could check out that Git repo. As an example, let's say, Bora has created the Git repo, I want to check out that repo, I can just check out. It comes to my machine as a working directory. And if I make changes, I stage this file, and then when I am happy to check in, I commit this file. It's a very high level three-step that we follow, right? So what are the cycles that goes through? Like we saw, initially when you create a file, it remains untracked, meaning Git is not aware of this file. You're not told Git to track it, right? So when you add the file, remember I did Git add. So that time it goes through staging, and then sorry, it goes here. Sorry, this one I'll come to that. That's the reason why this flow is there. And then when I commit, it comes here. Since the file is unmodified, and when I again edit the file, I again follow the cycle. So if you see this, what this diagram is depicting is, again I can edit the same file. I can say more stuff, more code goes here, right? I keep writing more code. I come here. If I say git status, it says file is modified because I modified the file. Basically, Git is already tracking the file, and it does understand compared to what it is tracking, the file has been modified. Now, what I can do, I can say git add part. I'm moving the file to staging. I'm not moving, I'm actually adding to the staging. Right? Now, if I say git status, it says modify, but it says changes to be committed. But in the previous stage, before I executed git add, it was saying changes not changed for commit. right? Just 3 steps. One is working directory, where I am doing vi demo.java and where I am doing my edits. When I do git add, it goes to staging. When I do git commit, it goes to the git repo. So if I do git commit, my second was changed. So obviously it's a bad command, right? So I'm just making it fun, but obviously in real world you will actually give appropriate command. Now if I do git status, this is nothing to commit. Basically everything is committed, it says working directory is clean. So we come here, essentially what it is showing is all these operations only, right? So initially I added a file, an untracked file. I added, it went to staging, and when I commit, it remains unmodified. When I edit the same file, it becomes modified. Again I do git add, essentially I am staging the file again. When I commit again, it becomes unmodified. This is a basic step. So Git supports 2 types of commands. The commands that we use on a day-to-day basis. This is like a git add, git commit, all these are day-to-day basis commands, right? That's essentially called post-line commands. There are more advanced commands, what you call plugging commands, which for all practical purposes we don't need to use it. The post-line commands uses plugging commands, but we will cover both of them just to get the internal understanding, right? Git init, we saw how do you initialize a git repo? You do git init repo. And if any of you are not able to follow, please stop me. Yeah, it's okay. Git add, essentially this is how we are telling Git, please track my file, right? So we do git add, git commit with a particular command. We just saw this. We again went through all these 3 steps. File is in all these 3 steps, right? Working directory, staging, and then Git repository. And what is a Git repository? When I say Git repository, it's nothing fancy. Essentially, there is this directory called .git. I hope all of you can see this. So .git is our Git repository, right? As simple as it. And if you see what is inside .git, there's a bunch of things are there. This is what we are going to cover in maybe another 5 minutes. So that's all. Again, more commands. If you want to remove a file from Git, if you want to tell Git, please remove, please don't track this file and remove this file, you do Git rm. If you want to rename a file and you want to tell Git, please rename, because Git also has to rename, right? It's a Git move. It's all, as you can see, it's all heavily inspired by Unix and Linux commands, right? Git move, old name and new name. Git add, we saw, we can add a single file, we can add the entire thing from current directory, or we can give a directory name and add it. There are multiple options. Git status, we saw, at any point in time, what is the working directory status? Modified, unmodified, committed, not committed, everything like you will know. Git config essentially is it's a command which kind of tells you can configure these things. For example, username says Prakash Subramaniam, right? So if I want to override, I can just do git config and then override this. So when I commit, so if I look at the log, right, it's saying Prakash Subramaniam. Where is it coming from? So obviously it's coming from the config. Email ID is coming from there. There are a bunch of configs you can do. I'm hoping you are probably aware of some of these configs. Even if not, it's okay. I mean that's not important for this discussion. Git log, we just saw git log. Git diff, just like Unix or Linux diff, git diff will do 2 diffs. For example, we can take this commit and then this commit, and then you tell what has changed. Essentially, same as diff command. Right? All simple things. Right? Git clone. When will you use git clone? We'll come to this later. I think it's currently for this discussion it's not important. We'll come to this later. I'll pause here. Any questions so far? Anybody who has not used Git might have some questions. So any questions from anybody? Because yeah, I think the Git. So whatever we discussed so far, just to ensure that we are on the same page. From now on, we're going to go deeper into the Git. So if you have any questions, please ask. Otherwise, I'm just going to move forward. To understand the Git internals, we'll be using a bunch of what you call plumbing commands, or you can say advanced commands, right? Which we, for all practical purposes, we don't need to use for our day-to-day development, but this will actually help us understand the Git really well. So Git repository, like we said, what's a Git repository? We have so this .git is essentially the Git repository, right? It's just a directory. This is actually a Git repository. Essentially has an object store. This object store is essentially like a key value store, right? It's a key value store, and it has something called index. And what does object store contain? It contains blocks, like a binary large object. It's when you say binary large object, again it sounds complex, but it's a simple gzip content. If you have a Java file, you gzip it and put it in a meta form, and that's essentially a block. A tree object, commit object, and tags. So what are these? We'll just see this shortly. A block object essentially stores file content. Like when we said demo.java, whatever is in the file, like demo.java, when you do git add and git commit, goes into this, right? Not even the file name. Demo.java as a file name will not be stored in block. Only the file content is stored in block. Essentially, Git tracks content. In other words, it is a content addressable file system. What do we mean by that? I'll just again take another example. So if you look into Git, so there are this bunch of directories it has, right? What will be interesting to us is look at these objects. So all these objects here are nothing but blocks or trees and things like that, right? So if you do git log, you've got the second commit, which is this. This is essentially represented by a SHA-1 hash. So if you see the hash here, what is that? Okay, it's here, sorry. Whatever is here, it's a SHA-1 hash. The hash of what? It's a checksum of the content. So if you come here again, demo.java, it has this content, right? So what I will do, there is one plugin command called hash object. I can do demo.java. How many times I execute? It's just doing checksum of it. It's essentially hashing. It's hashing that content, right? And what is the output? It is 20b1 whatever, right? And if I check .git, you will have 20b1, all these things. Like I was telling, it's a key value store, right? The key is the SHA-1 hash, value is inside this file. Right? So how you can verify? Just do git hash object, and it's just a SHA-1 hashing, just a hashing algorithm. So very as simple as it, right? And you can execute that in many ways. Like you can do some test content, right? It can be any content you want to do from stdio, right? It will again give another hash. It's the same hash it will give. It's a hash of test content. Any content can be cached. Sorry, can be hashed, right? So what if you have got two files? So what I do demo.java into demo copy.java, right? if we do git hash object and then demo copy.java, what do you guys think will happen? What checksum will return?
Same.
Would it be same or so basically I do this or get hash object of demo.java. The file content is same. So what should it return? Should it be same hash or different hash? Same? Everybody thinks different? Okay, who thinks it will be same? Okay, what do others think then? No idea? Cool, it should be same. Essentially, it's because it is hashing the same content. Like I said, the file name is not counted for the block. It's only the content that is counted, right? So when you hash the same content, there's a probability. I mean, it's like there's a thing. I'm forgetting, is it million or billion? Ashok, do you know the probability of that collision? The collision meaning, the collision meaning, the collision would be, for example, for a different content, is it possible to get the same hash? There is a remote possibility. The remote possibility we are talking about is like 1 in billion or something, I think. Especially a very rare possibility, right? So for all practical purposes, it doesn't matter, doesn't count. I'll go back. So what is a tree? Essentially, a tree directly maps to a directory. Like in a Unix file system or a Linux file system, a directory would have subdirectories. Again, subdirectories would, and then files, of course. Subdirectories would have files and directories and so on, right? It's a complete tree structure. It just maps to the same thing, right? So very simple. So if I go back to the example. I think for now I'll just take the practical example little later. So what is a commit object? Commit object points at a tree object. So what does it mean? So if you look into this, you got a tree. So commit object has a reference to a tree object. It also has a reference to a parent commit object. It has an author. It has a committer. So if we go back to our example again, so into git log, we have this commits. So there is a commit object. If you want to see what is in the commit object, there is a plumbing command called cat file. You can kind of peek into that and see what is in it, right? This says this is essentially a commit object. If you want to know the type of it, right, you just have to say T. It says commit object, right? So this is a commit object, and what does it contain? It points at a tree object and parent. So what's the parent? Again, we will see soon. Author is Prakash Subramaniam, committer is, most of the times it will be same, but sometimes it can be different as well. It's not important for now for this discussion. And then this is my message that I gave for committing. Essentially, when I said commit and I gave a message, that message is this message, right? So what is this parent? When you do git log, see this. So my first commit, I did a first commit, and then I did a second commit. So parent of second commit is the first commit. Now if I do another commit, so if I do vi demo.java, I say more and more changes, then I save this, and then I add this, essentially state this, yeah, and then I commit this. I say this is third commit, right? Now if we do git log, there will be 3 commits. This is the latest commit. So if I do git cat file of latest commit, it should say parent commit is B7 whatever, right? So it says B7 is the parent commit. And if I take that commit and then ask it, actually it will say my parent commit is 90. What is that? That is the, when you did git log, right? This is the 90. That's the very first commit we had. And if I take this commit hash and then ask who are you, this does not have any parent because it is the very first commit, right? There's no parent in that. But it still points at tree object. We saw commit object. So what is this tree object? Like I said, tree maps to the directory structure. So if I do git cat file of tree object, this tree object, it says, it points at the blob, a blob object, and then it says name is demo.java. Essentially, tree object contains name of the file, not the blob object, right? So if we look at this structure, it will be a little more clear. So it's like this. A commit object points at any time, it points to a tree object. A tree may be having subdirectory and files. So for in this case, it says the tree is saying I have a readme. I have a blob, essentially file called readme, and I have a subdirectory called lib. And the subdirectory again will be represented by another tree object. That subdirectory again has blob called mylib.rb, and then another subdirectory, and another subdirectory has a file. So if you have to represent this in a directory, so this directory would be like this. So this has, so the top level there is a commit object. So there is a tree. The tree has a readme. Let's create something, right? So we'll say mkdir, or let's say something for demo2. Okay, just for this one. So the top level you got a readme file, and then you got a lib directory, and then you got the lib directory has mylib.rb. So if you go to lib, so there's mylib.rb, and then another directory, subdirectory called inc, right? And inside inc, you got tricks.rb. You go to inside inc, you got tricks.rb. That's the structure we are dealing with. So if we go here, so this structure, what you see here, there is a readme at top level. There is a subdirectory called lib, which contains another subdirectory called inc. But the lib subdirectory already has another file called mylib.rb. This subdirectory libinc has a file called tricks.rb. Right? This exact structure is what is represented here. Yeah. And each of these files, like readme file, has some stuff in that. The essentially file content is that, which is represented by a blob. But the file name is still in the tree object. Again, same thing here, like mylib.rb has some Ruby code, but the file name is here. Likewise, tricks.rb as well. Any questions so far from anybody? No? Alright. What is tag? Tag is a very lightweight object. Let's say you want to release a software, right? You want to name it, for example, maybe release one, or maybe like a milestone one, whatever you want to call it as. You can just tag it. You just say git tag, whatever that person you want to tag it. It will just be pointing at, tag will just point at the commit object. It just needs to do point at a commit object, right? So if you see holistically, the tree structure will be like this. There is a commit object which is pointing at the root or top level tree object. That tree object has blobs, essentially files. And what is a branch? Like a master, because we use Git, right? There's a master branch. Master branch is just a reference pointing at a commit object. And again, tag is pointing at a commit object, right? You have, let's say, second commit. You make second commit. So this second commit, we just saw that. Second commit always has a parent pointing at the first commit. And the reason why you are doing second commit is because some file has changed or some directory has been introduced, right? Which means the top level tree object has changed, but assume that these two has not changed at all. The previous blob, whatever is there in the blob, has not changed. If we had to model the same thing in the directory structure, right? So it will be something like this. Essentially, you got the top level. I'm going to remove everything what I got here. So let's say top level is empty. Sorry, nothing is there, right? So we just go here. So you got a top level a directory which has two files, right? Which is det23 and feeble. So if I come here, it has got two files, det23 and feeble, right? Two files. Maybe there's some content. We just put it so that we know okay there's something in there. Det23 and content 2, which is feeble. Yeah. So now if we just add everything, first commit. This is the first commit. So this structure exactly represents this. There's a tree object. Sorry, there's a commit object. We do git log. Okay, sorry, I don't think. I'll just remove the old git folder we had so that we have clean start. So you do git init, git add, git commit, first commit. Good. This will be good, I think. Okay, so this is our first commit, which is this object, something like this, which is pointing at. So what is the commit object pointing at? It's pointing at a tree object, which is this. And if we ask tree object, what do you have? It will say I have two blocks, right? Det23 and feeble. This is that state. Now imagine I introduce a subdirectory, right? And the subdirectory contains a file. So we'll have a subdirectory, maybe something like a lib, and the lib has some file, something I don't know, some stuff, yeah. And then some stuff also has some content. And then I come back, I say git add everything, git commit. I say this is my second commit. Now if you do git log, there are two commits. Yeah. If you take the latest commit and I ask commit, what do you have? It will say I have a parent commit, which is this. This is the second commit, right? We just did. This commit has a parent commit, which is this. And I am pointing at a tree which is this tree, and this tree contains two blobs which has not changed at all. We do not touch the blob at all, right? So this remains same, but it has a new subdirectory. There is a new subdirectory which is represented by this. And if you ask this subdirectory, what do you have? It will say I have got some stuff. Essentially, is the file name we had, right? Which is this blob. Good so far? Any questions? I know it's quite intense, but is it confusing anybody? think we did some git cleaning and all. So one more thing what I want to show is yes. So what if we have got another file? So we got date2 as the file name, right? I think we already covered this. Let's say I go to lib directory. Again, I create another file. Let's say second file. Yeah. And then second file also has something called content. Right? In other words, we have got two files. Second file has something called content. And the top level directory, you've got det23 file which also has content. Now if I add and commit, again what is the commit? How many blocks will be there? So this is the directory structure, right? So again, let's sorry. What I do? Yeah, okay. Okay, so there are two files here. And if I do find or lib, it has another two files. Right? Essentially, there are four files. But as we saw, date23 and second file has same content. So how many blocks will be required? Any thoughts? Three? Alright. I lost each of you probably. How many of you do you think we required? 3? 4? Right? You guys are creating. Any of you think differently? 4, 3, 2? 2? Who says 2? You're saying 2. You're saying 2. Okay, alright, you're saying 2. Alright, any other numbers? Cool. Let's just see. Right, so we've got two files in the top directory, which says date23, which has content. The second file has something called content2. And then you've got another two files in lib directory. The first in that has some content. The second one has something called content. Essentially, two files have same content. The other two files have different content. Yeah. So let's see what Git does. So I'm going to add. I don't know if I already committed. Did I commit already? I think I already committed. Cool. Let's see what Git has done. Right. So we do git log. I mean, it's just a git log. I just have a shortcut, so shorter version. So git log. Okay. So let's take the latest commit because that's what we can as of now, right? We took latest commit and then we ask, okay, latest commit, what do you have? So latest commit says I'm pointing at the tree object, this tree object. Git, remember, commit object always points at the tree object only. Simple, yeah. So now let's ask tree, because tree is just a directory structure, right? So tree structure, what does it contain? The top level tree says I contain block, two blocks, date23 and people represented by the hash 39C EA something like that, right? It also says I am also having a subdirectory tree represented by this one. And let's ask this tree structure, what does it have? It says I have two files, essentially two blocks with hash this and this. So essentially how many blocks it has? 3. So this block, as you can see, when the content was same, essentially whatever was inside the file, when it was same, it did not create a new block. The reason why it's able to do that is, remember we did the hashing, right? So when we go back to the structure again, this structure, maybe, right? block does not contain file name. The file name is at the tree level, right? So if Git gets same file content, it just needs to do hashing, essentially checksum, and if it is same as the one that's already existing in its object store, does not have to create a new one. Even if it creates, no, how will it create? Think about it, right? If it has to create, it has to write into the structure, this directory structure. It has to write into this object structure, and the way it writes into the object structure is like this. The hash is what goes into the object name, like a blob name. So even if it writes, it will just simply overwrite, because when you do git hash of same content, it is going to do the same hash only, isn't it? It's very simple. It's a very, if you think about it, right, in hindsight, like looking back, it's very simple, data structure there we have. Was it clear to everyone? Essentially, the hashing I'm talking about, I think a couple of you came a little later. The hashing I'm talking about is this one. So when you do, it's a SHA-1 hashing. When you do hash on content, how many other times you do on the content, it is going to return the same hash output. Yeah. All right. And that's one of the reasons why it can be so efficient. I think the second benefit of hash, we saw this at the file level. What if you got a big directory structure? Let's say you are doing git diff, you have got a big code base, let's say, right? Big code base, you want to do git diff between two versions of the code base. And with this structure, all that it has to do to diff, think about it, right? Let's say you did git diff between this and this. Yeah? The moment it sees hash of this and this is same, it knows it's same. The same applies to directory level as well, directory structure level as well. So what do I mean by that? Let's say there's one more level, one more commit. So in our case, we had that one more commit, right? We had this git log. If we have to diff between these two versions, right? What are the change we did here? In this change, we introduced subdirectory. In this change, we introduced another file, right? So with this structure, it knows that, imagine there's one more commit object here, which again has a tree here. But this tree, if this tree has not changed at all, the tree hash will remain same. So it doesn't have to go inside the tree and explore everything, right? How many ever nested directories? It can be like 100 files or hundreds of directories inside. The top level, the tree has remained same between two versions. Does not have to go inside at all. Right? It's very efficient that way. I think it's able. I wish there is a board. Essentially, when you think about a multi-level tree structure, I'll give you a simple example. I hope that you can visualize. Let's take an example. Probably I can just demo that here. Let's assume there's nothing here. Yeah, let's just keep it simple. Maybe I'll open do it in different one. NKT or demo 3. Cool. Demo 3. Cool. So in this one, so let's say we have subdirectory 1, subdirectory 2, and subdirectory 3. Yeah. And each of this subdirectory has hundreds of files. Yeah. I assume that it's hundreds of files. Again, each of the subdirectory has hundreds of files. Now, if I go and change a particular file in subdirectory 3, imagine, let's say I add a file, I add a new file, right? Sorry. new file. So imagine the two commits actually, right? So first commit what I did, I committed with all these things I committed. Yeah, first commit. So I then commit here. There's more here. I don't know if there's more stuff here. What I do now, I go to subdirectory 3 and I add one more file, second file. Yeah. And then I do git add, git commit, next commit, right? Some meaningful name. Now between this commit that we just did, which is the last commit, and the previous commit, what was the change? There are three subdirectories. In the last commit, we added a new file in subdirectory 3. Other two subdirectories we did not make any change at all. So all that it has to do is compare those subdirectory hashes, and if it remains same, it does not have to go inside at all because hash remains same, right? That's essentially how it can be so fast, essentially. Right? Any questions on that? Pack files, probably we don't need it, I think. The last concept we wanted to talk about is directed acyclic graph. So Git architecture is essentially that, directed acyclic graph. Each circle that you see here is a commit object. So when we did the first commit, that's the first object. When we did the second commit object points at the first commit object. Third commit points at the second commit object, and so on. So it should be a linear, it's almost like a linked list, isn't it? It's like a singly linked list. So why is it a directed acyclic graph? The reason is branching. When you do a branch, let's say you are doing a branch from here, right? So the branch you start committing here, right? So this essentially again has its own path you take, right? And what's happening here? You're actually merging here. You're merging the branch to master. Yeah. So imagine this like a master branch in Git. If you're not familiar with Git, if you know subversion, for example, trunk, that would be your trunk, right? This is like a master. You branched off. You did some changes. You're merging it here. Again, there's another branch here. You did some changes, but this is not yet merged. So there's no merging happening here, right? There's no merge at all. So we know directed acyclic graph data structure, right? So it's typically the vertex and the edges. You typically have the edges going towards like one way. It's not cyclical because you can never come back here. Like you cannot come back. It's always like one direction, right? It's a very simple data structure they have adapted in Git. It's a directed acyclic graph, but it's very efficient as well because of this, right? Essentially, like we discussed, there's one more view which will indicate this. This is actually index. That's not good. Yeah. So this circle is essentially like commit object. What we saw there, the directed acyclic graph. Each of the commit object points at the tree object. Tree object points at the block. Again, under commit object, which points at a new tree object, which still points at the old blocks because the block has not changed. But here there's a subdirectory that got introduced, and so on, right? It's a very simple data structure they follow, like a directed acyclic graph, but they're able to be very efficient. And the important thing is why is like branching. Everyone will say branching is very efficient in Git, right? That's something I had some slides about that. So there's a concept of refs. So if we see here, right? When you do Git status, not this one, maybe I'll go to demo 2 maybe. If you Git status, it says I'm on branch master. So what is a branch in Git? It's very simple. If you go to Git, there's something called refs. There's a folder called refs. And we check what's inside, something called heads and tags. And what's in heads? There's something that says master. So what's a master? It just contains the hash of a commit. So if this was commit, this was a commit object, right? A branch, that's what you see here. A branch always points at the commit object. And in the DH we saw, like master is pointing at a particular commit. Another branch called P or 17 that is pointing at another commit. Another branch dev is pointing at another commit. So the cost of branching in Git, what's the cost of branching? Any guess? Essentially that's all. 40 characters in Git, right? Cost of branching, cost of tagging, everything is just 40 characters, right? It's very efficient, right? So there's something called refs, and then there is another one called symbolic refs or symref. So what's a ref? Essentially, whatever is inside this, right? Each of the branch is a ref. It's just a reference. Basically, it's a pointer. Simple, right? Imagine like a pointer. What's a symref? That's again another very simple concept. So you might in a Git repo you may have multiple branches, right? You may have master, you may have dev, and so on, right? So how does Git know which is your current branch that you are working? Your directory which branch you are working on, right? So that information it stores in this one called head. You can see head, right? So if you do what is in head? What's it saying? Oh, sorry, I had to go to the previous slide. Sorry. Inside the Git folder. So if I do Git folder, right? If I do get head, it says press heads master. Essentially, let's create a new branch. Okay, then it will be clear. Let's say I create a new branch called checkout B. Maybe some, I don't know, my release to may I want to work on this maybe, right? So I mean, if I do git status, and it says I want branch release to, yeah. So now let's see. If I go to the Git repository and then see what is inside Git, it says release to. Essentially, it's telling the current branch that I am working on is release to. Otherwise, Git has to know somehow that I am in that branch, right? So it's a ref to it's a reference to a reference. That's why it's called symref, right? And then if you see what is inside this, it will again have another hash, right? So if I go to if we check what is inside refs now, refs now have two branches, both the branches stored here, like a master and release to. If I create one more branch, it will be one more ref, like one more pointer that needs to create. It will be pointed to a particular commit that I had, right? Again, tags, again very similar. You can tag any particular commit that you are releasing, right? And that would be again another 40 characters, right? It's very cheap to do these things again. I'll just pause for a moment. Any questions? Anything that I think that you may already seen, right? There's one concept I not covered, which is index, the concept of indexes, right? So remember we said there are tracked files, ignored files we will ignore, untracked files. But when you do something called staging, when you do git add, we discussed it, the file goes to staging. But when you do commit, it goes to git repository, right? So what is staging? So where does it store? Again, if you look into this structure, when you have checked in everything, right, you have working directory. Imagine like this again simple example. Your code base or your project contains two files, foo and what. You have checked in that, so your object store also contains foo and bar. Yeah, and there's a branch. There's only one branch, master. So master branch is pointing at a commit, the very first commit. There's only one commit, and this commit is pointing at a tree object. The tree object is pointing at these two blocks, right? Given that you would have done git add and git commit, the file would have gone to staging also, right? That's actually index file. So index file will have this tree structure, a tree object, which again refers to the same blocks. Let's take an example. Let's imagine we are modifying this file. The foo file, whatever is the foo, right? We are modifying to something else. Yeah. At this stage, but you're not done git add it. It is there only in working directory. So git does not know about this change. Right? Basically, git is not tracking it. Now you are doing git add. Yeah. So you do git add. Still you are not committed it. It is still in staging. Yeah. When you do git add, you are pushing into staging. So this file, the tree object, right? The tree object which was pointing to this block will start pointing to a different block now. There's a new block because the content got changed. So this starts pointing to this block. But the second file, the block remains same, so it doesn't have to change. Now when you commit, working directory is like this. Index is pointing at this. But because you committed, so git object store is also aware of it, right? So there's a new commit object. Master branch is pointing at a new commit object, which is pointing at a new tree object. The new tree object, so there's an error here, that's why the red color thing is there. The new tree object is pointing at a new block object and then another old block object. Basically, this block has not changed, but this block has changed, right? So the new tree object is pointing at unchanged block object and then changed block in the new one, right? Was it clear to everyone? Confusing to everyone? Cool. I think that's all I wanted to cover. There are always some topics that we can keep discussing, but that's like never ending discussion, right? So there are a lot more things we can talk about. Like git tag, I think, like tagging, right? Again, I spoke about when you do git tag, again, it's the same thing, it's just a reference. Yeah. So that's all I wanted to cover. I think it's already, we're already run out of time, I think. Thank you. If you have any questions, we can discuss.
I have a question.
Sure.
Let's say I'm changing a file permission from a particular file.
Yeah.
So that will committing it, that will create a new commit ID.
Yeah.
So where the
File permission will not create. You can't commit. File permission is not a file change now.
But we can change the file permission. And
You can change the permission.
And also I can push that change.
File permission change alone can be pushed as part of the commit, but it's not part of the file contents that is tracked. So it is tracked only in the tree object.
Okay, that is one of my question. Where does that change get affected?
That's part of the tree object itself. The file name, file permission.
Yeah, any metadata goes to tree. That way. You are talking about the CS mod file change. Is it?
Yes.
Oh, okay. Any metadata stored in tree, including file name. So the block does not know file name. So that way. Any other questions?
Yeah.
Yes.
In your experience, would you prefer rebase or watch when you try to?
So it's an interesting discussion. So both has its own pros and cons. When you merge, some one concern would be, your commit history becomes polluted with merge objects, right? That's one concern. But of course, we are merging a branches, then it should be definitely a clear merge object, right? The rebase, downside of rebase is it's almost like a time is not aligned. Meaning, what I mean by that, imagine like I have changes made. I should not have that. Let's say, imagine like I have 5 days old change. Basically, 5 days old commit. And then Ashok checks in today something, right? His commit has gone to central repo. So when I pull rebase, what would happen? My commit would be in the top of the graph, or that graph, right? So it doesn't maintain timeline. That's one downside. So when you do again when it goes to continuous integration server, it will build and say the changes were like 5 days old, right? But the previous build will be like a today's build. So I mean that is the one downside of that. My preference is for branch merges. Obviously, it should be merge, proper merge. If it is regular check-in to the same branch, and that's actually where if we follow continuous integration properly, right? We check in frequently, few times a day. Then I think rebase is my style. Again, there are different schools of thought. I'm sure there may be others who think differently as well. That's my school of thought. But yeah, I mean everything has its own pros and cons, right? So that one problem downside with the rebase I think is that time reordering, right? That happens. Any other questions? Cool. I think we are done. Thank you guys. Thank you for your time.
We'll get started, then other people come in. So before I start, my name is Karthik. I work for Cisco, Bangalore, right? I work from Bangalore, basically. Okay. I'm a DevOps engineer for one of the security products of Cisco, web and email security, right? So what we're going to cover today is about predominantly we'll start with Jenkins, and we'll get into a concept of pipeline in Jenkins. Today, I don't know about the audience, so we're going to cover very basics of a simple pipeline. I'll also talk about how to use extended. So what is the way forward with the pipeline, right? So before I start about, so I just want to get the audience. So how many of you are working? How many of you are students? Could you first working? Okay. Right. Okay. So the rest of our are students. Okay. All right. So how many of you know about what is Jenkins is? I mean, some. Okay. All right. Okay. So what I'll do is I'll just give an introduction about what is Jenkins. So Jenkins is one of the open source tools available predominantly for continuous integration. So it's a project that came out of Hudson. Earlier in the open source world, Hudson was popular, but once that was hosted by Sun Microsystems. And once Oracle acquired Sun and the project Hudson had to be moved away from Oracle, and they named it as Jenkins, right? So Jenkins is very popular. You have an enterprise version of Jenkins today. That's cloud-based. You have a lot of plugins available today for Jenkins. So take any service, they put it in as a plugin, which is available for free, right? So when I say continuous integration, there is a term which says continuous integration, continuous deployment. You might have heard about it. So today we're going to talk only about continuous integration. We're not going to talk about continuous deployment. So that's what, in short, it's called as CI, right? So what is CI is in a distributed environment. Like you have for Cisco, you have an office across the globe, right? So you have developers working across multiple time zones. So we use a repository. So the developer comes in the repository. So there is a tool that just does the build. So that's the tool that does the build is Jenkins. And as part of that process, right? As part of the build process, we just don't build it. We do the testing. Unit testing is done. Certain the minimal tests or batch are run via Jenkins so that to ensure that the build is good enough, right? So that they can be given to manual QA to perform other set of checks. So the process from where the developer continues to commit changes and builds, and then as part of the testing that happens, right? I mean, it gets deployed in a test system and testing happens automatically. So what's the testing that's going to happen is the basic set of functionality, right, that is supposed to work in a product is all part of the test suite, right? So if I generate a build, if the basic set of tests itself is failed, that means the build itself is not good, right? So that's what continuous integration is all about. So as I was saying, why do we need this? I mean, just to globe, you see people from multiple places coming in, and before I get into this workflow, what I want to tell you is yes, Git is good. I think Prakash explained it very nice. But in real world, where there are projects, the project I work in has a million lines of code because it's 15 years old code base. So Git does not work well for us. We use Perforce. Perforce in terms of performance, Perforce is Git. And I know Facebook uses Berkeley. They use Git, but they have also a performance problem as well. So because if you listen to what Prakash was saying, everything is a memory reference, right? Everything is a SHA. So you should be very careful when you're working on a Git, when you're in a project. You should ensure that you split your repositories into multiples. Like if you have a components, all your components has to be a new repositories in itself. You shouldn't dump everything into one single repository. Otherwise, as your project or as your code base grow, you will face performance problems. So the other area where Git did not work for us is because our code base had our binary files in itself. So when we were trying Git, because of binaries there was a slowness, because think about SHA for each binaries, right? So for a binary file, for a text file, it's fine. You get a SHA, right? You get a same set of SHA for same set of text files. But for binaries, you get a new set of SHA instead, though it's binaries. I mean, binaries cannot be. It's all ones and zeros, right? So that's another area we did not have. We have a performance problem. So that's why we chose Perforce. But in Git, there's, it's a Jenkins talk, but I just want to give you a little bit of Git, why we're not using Git. Git has an LFS concept where this is very popular. So if you guys are using Git, take advantage of using LFS so that you can put all your binaries, mark it as an LFS, and then have an actual code in the code base, right? So coming back to Jenkins. How does this work? I was saying, could someone tell me how to use this? Sorry, this one.
Did you attach
Yes, you need to.
Okay, there's some setup assistant there. Okay, otherwise I will be able to show the hands and all that. So now how do I find it? Okay. Thanks. So this is a developer typically doing a code, right? So whenever a developer normally does the code, he just tests it in his own environment, right? Then he does give it to the peer review. So in a corporate world, whatever you do, right, will always be reviewed by other person in your team itself, because you might make some mistakes. Humans are prone to errors, right? So after peer review, it goes to things are pushed. Because multiple developers are working on it. So they do the push. Once when I mean push the commit, right? So then Jenkins comes to the picture. So for every commit, so you get a new build process gets generated. So that's where Jenkins comes into the picture. So Jenkins is just a tool which has a lot of plugins that will allow you to do the builds, right? So Jenkins is not does not connect everything into it. It is a way to connect your version control system, which is Git or Perforce or any other version control system, and you have a lot of plugins available to do the entire CI process, right? So when I get to demo, I'll show you how the old way of Jenkins jobs are created, so that you get a bit of understanding and what is the pipeline, what is the basics of pipelines. So what is the new stuff that's very interesting, right? So what's the pipeline? So whatever you provide in a manual effort was, let's say, for instance, you have to create multiple jobs. When I mean multiple jobs, to put it in simple, let's say you have a set of steps, and your bills are running for like 3 hours or 4 hours, and it fails at one particular point in time, right? So think about it. You have to drag the entire 4 hours logs to see where the bill, why is that bill failed, right? So, but with a set of pipelines, you could even split it and say what is, I mean, for instance, a code checkout can be a part, or building of a certain module can be a part, and so each module or each component building can be a separate parts. So you will be able to see where, I mean, when there is a failure, you'll be able to know which part of it failed because you define it clearly, and you can only see that particular point of log. So it's easier to view the log and find out where it is failed, right? That's the first advantage that I get with using pipelines. The second advantage that I get with pipelines is remember there, I would be able to see it right there, how long it took for each process. So let's say I do a build now, I see it takes 2.5 hours. The next build I see it as 3.5 hours, right? Let's say it takes 3.5 hours. I can immediately see which set of step that it took more time. So there could be some problem in it. I can go and identify, though the build is successful, I can go and see why it took more time in that particular step, so that I can debug it and see if there is some sort of problem, fix it, and then move on, right? So as I was saying, there are multiple types of pipelines. So one is I don't know if you heard about Blue Ocean Jenkins with 2.x. You have this Blue Ocean. So which itself has a pipeline project. It gives you so you put, there's a file called, I mean, you have to create a file called Jenkins file. The name of the file itself has to be Jenkins file. You have to put the pipeline steps into it, and part of the repository and do a build. And any branch that you create will automatically build because of that with that step, right? It shows nice pattern of how it flows and all that, right? So and the other one is classic UI, so which is what we're going to cover because it's a very basic pipeline step. Very minimal operations can be performed because Jenkins itself provides a syntax. But once you go advanced, then I would recommend you going to SCM, that is putting the build step, I mean, as part of the Jenkins file, put it to the repository and do that. But for a minimal, let's say you want to learn, if you haven't used pipeline itself, then to start with, I would say classic UI is the best place because you can learn all the pipeline code. It's easy to learn the syntax and move forward from there. So you might ask, why am I covering classic UI rather than doing it in SCM? I mean, why am I saying SCM is good rather than classic UI? Because what happens in typical world is sometimes developers in real world, they don't care about what happens in production system. They say it's a production system, it's a failure, and they say, hey, in Jenkins it's failed, it works with me, right? So, but they should know what is happening as part of the build, right? Most of the time they don't worry about it because it's a responsibility of a build engineer or a DevOps engineer, right? But if if you have your build steps as part of your repository, so they would also debug it inside the, because the build step is part of your repository. This repository, whenever you make change, if there is any change to that build step, or what is the process that's failing, so the developers are equipped to know why that particular build failed. So when you have your build step as part of, I mean, when you have this Jenkins file inside your repository, the pipeline inside your repository, right? So I'm going to quickly go into demo. I'll stop here for a bit before I get into a demo. Do you guys have any questions? Okay, I assume the silence as no, right? So I have some dummy repositories in GitHub. What I'm going to do is I'm going to show you the flow from a repository, what happens to Jenkins. So what's pipeline and all that. So first we will start with. So I'm running a Jenkins in my own laptop. First of all, this is the older version of Jenkins. So what happens is when you want to create a setup for a job or a build job, the first thing that you would do is you click here, you create new item, say super, something like this. So you create a freestyle project, right? If you look into this, the first thing that you would do is, because now that you have a Jenkins job, you have to check out a particular code. That's what you have a build, right? So you click on source code management. So I have installed a couple of plugins, which is Git and Subversion. So I'm just going to focus on Git because my repository is in Git, right? So let's take this repository or anything like this. So just go here. So I already have my GitHub credentials added. If you don't have your credentials added, you just have to click add and say your credentials of GitHub. Things will so it will get stored. So since I have it already added, I'm just saying going ahead, and it says what is the branch that I have to check out. I only have master. It's a simple repository, right? I'm just leaving it default. So once you have this, so there is a step here which says poll SEM. So what this poll SEM does is every time you commit, right, it keeps on polling and say whenever there is any new commit that's been pushed, it'll start building it. If you don't have this option enabled, you have to go and each time someone has to go and click on whenever there is any commit, someone has to go and click on build to actually run the builds, right? So we're not doing a poll SEM at this point. So I'm just going and say echo. I'm just writing a shell script. Hello world. This is a very familiar echo statement. So I'm just saying okay. So this is how a simple job would look like. So when you want a new build, then just you have to come and say build now, right? You get a new build. So it says what is the revision it has taken from where is this reference where is this revision reference, and you basically see this console output, right? So console output talks about what happened as part of the build process. So it says, okay, I checked out, I initialized this repository and I checked out this particular repository from cart120 comments.git, and then this was the commit message that was there. It was the latest, and after I check out, I just say hello world and it's successful, right? So what this does is we have checked out, but we just said hello world. But what you normally do is you have checked out the code, you go into that workspace and do something, right? So this is a very simple job. I'll stop here for a moment before I get into pipeline, because pipeline, we're going to do this in a pipeline. What is the advantage that we're going to have? So do you guys have any questions so far on this? Okay, silence means no questions. All right, so I go to a pipeline job. So how do I create a pipeline job? Is you're going to do that same stuff in a pipeline, right? So pipeline testing. So remember we chose a freestyle project, but this time we are choosing pipeline. So for this to appear, you need to have a pipeline plugin to be installed in Jenkins. I'll just show you for people who doesn't know Jenkins. I'll just show you where do we install plugins. You click on Manage Jenkins. You go to Manage Plugins. You go to Available. So you have a list of plugins available. You just click on that, and at the bottom of it, you have to click on Install without restart, or download now and install it restart, whatever it works, right? So this is the plugin. So one of the plugins that we talked about is the pipeline plugin, right? So pipeline testing. So I created a pipeline project. Now that you don't see the source code management, build steps, and all that. So you directly come to pipeline, right? So this is the simple pipeline syntax. So the easy way to do is you could try a sample pipeline. You have a hello world pipeline. You just have to say hello world. But here, what we will do is what we have to do is we have to remember, we have to check out a code, we have to say hello world, or we have to execute some scripts, right? So the beauty of this is the syntax is provided here. So you just have to click on this and see the syntax. Let's say you want to do a checkout of a repository. You just have to come here and say checkout general CN. Because you are starting pipeline, you would not know the syntax, you might make errors. So start with this and say, what's the URL? Just put that URL. You have to say my GitHub account, and whatever I gave there, I'm just saying master. I'm saying generate pipeline script. So my pipeline script is generated, right? Right. So this is the okay. I forgot to say that it's a DSL commands. Bit of Ruby, if you know Ruby language, you will cast this easily, but you don't need to know Ruby to learn pipelines, right? Because the syntax are all pretty simple. You just have to learn it, get it once, so that your job will be repetitive of that same whatever the syntax will remain the same. Your scripts will vary. So here I said include in polling, include in change log. If I uncheck this and generate pipeline, the change gets varied as well, right? So now that you have this stuff, let's go and start the pipeline. Now I'll go back to this and say, let's start with pipeline. So node. So it always have to start with a node, okay? Before I get into node, I say agent any. Okay, so what does this agent refers to? So what happens is you have this Jenkins, but now we are just building it. The build all happens in Jenkins itself. But in the real world, you will not have the Jenkins machine itself doing the build. Jenkins will act as a master, so you will have a lot of VMs will be added as a slave to Jenkins. So your build happens in these slave nodes. I mean, not in this actual Jenkins server itself, because because if you want multiple builds to happen, multiple branches to happen, you need to run it on slaves rather than running it on Jenkins, right? So the other advantage that you have is you don't need to have all the softwares that are required have to be only in the slaves, not in your Jenkins master, right? So having said that, so agent any refers to run. When I say agent any, I'm saying you run it on a build slave or you run it on a master. Here we don't have slaves, but we are just running it in this. But let's say you want to have certain tasks to run on a particular slave and not on a different slave. Let's say you have 10, out of which 5 build missions are Windows, 5 build missions are Linux, and you want a certain step to run only on Linux. Then you have to, for every slave that you create, there will be something called label. Label refers to the name of that slave, right? So you can say agent space that slave's name specifically for Linux or for Windows, and then start working on the steps. So that at any point of time you do the build, it will only happen in that particular 5 or 4 or 5 slaves, right? So node is where you once you start with the node, you get into stages. So stages is where I'll just copy I'll copy the sample script considering the time. Where did I keep the script? I'll explain this. So, this, maybe I'll expand the other steps. So what we are saying is this command that we pulled it from, right? This is not required. Okay, so stages. I was telling you about you're going to have components. You have to build it in different categories, right? So that's called stage in pipeline. So whatever you put it in a particular stage. So I'll just show you the sample to make you understand. So you see this, right? Source code checkout is a stage. Build scripts execute is a stage. So I can just go on here and see the logs of particular stage alone, right? So this is just a dummy one. So now that I think you get an idea of what you need to be in stage, right? So the first stage I'm saying is source code checkout. I just copied whatever syntax I got here. From here, I just put it here. Okay. So, and inside this repository, well, if I want to reproduce what happened in the previous step, I would just say. So this could be anything, right? So whatever you put it here will come in your pipeline topic. So I'm just saying something which is print my world, right? So here I have to say echo lower, right? Alright, so if you see that the comments are with double slash, the reason why this is always a good practice because here you have too much of braces in order to understand where your which braces is for what. it's always good to put the braces, right, so that it's easy to debug. So when I do a build now, you see that source code checkout was a stage. So now the source code is being checked out, and it says print my word, right? So it says that process is also completed. So instead of looking the entire log, I can go here, I can look at the log like this and see what has happened, right? The other way of doing it is to see here logs and see only this particular stage alone. Similarly, this particular stuff as well, right? So hello world has been printed, right? So for the simple steps, you may not see the advantage, but in a real world, when you have as I was saying, when you have your bills are running for hours and 24 hours, and all, there are bills that run for 24 hours because you have hardware and all that, right? So especially this set of pipeline will help you out. You have all the functionalities, whatever you have it in the normal system, like building with parameters. You have a post job, after post build steps. Everything, whatever you see in the normal job, can be integrated in pipeline. So I think that's what I have. I hope you guys have got some idea about what to do, right? So similarly for shell script execution, again, because most of the time you either write a shell or a Python script to do the build, right? So that's also defined here if you want to know what is the shell script. So sh is the command. So you just put it, you just type the shell script name and generate, let's say test.sh is my script, and I come and generate pipeline script. It just generates, it just gives you a command. I just take it and use it in the pipeline job. So having said that, this is going to be useful for your large bodies. I'll just stop here. I'll leave this forum for questions. If you have any questions, you can talk about it. Okay, so come to Jenkins. You go to manage Jenkins. So you have the slave option, manage nodes, right? So you have to add a new node, okay? So you just have to say the name. You have to give the details about this agent. Let's say you have some node, you have to give the details of the agent, and it asks you for your username, the post name of the slave, and it asks for the credentials. So once you put the credentials, it automatically goes and runs the jar, Jenkins jar, the client jar. You have to give a path where that jar has to run. You just have to do that, and it will automatically go and runs the jar. If everything is good, let's say you give a username that has permissions, right? It will go and run it, and it will get connected. It's as simple as that. So if it has some trouble, it will say what is the error. Let's say you don't have permissions on a particular folder for that particular account, and you are trying to run. So that will become your workspace. So whatever the Jenkins jar is run, it will become your workspace. You don't need to physically. It has to be in the same network as long as it's normally slave nodes are all virtual machines. As long as it's in the same network, it's good.
Or in case any of the slave agents, like what will the Jenkins do? So will it do the same job some other slave will do something?
Yes. Yes. So what you need to do is you have a job. Let's say I'm going to show a sample job, right? So there is option here on there that sorry, this is again Python as well. I will just show this. Where is this coming here? Okay, so there should be an option here which says what is the slave that you can run your bills on. If you do it with pipe, like 2 pipes like this, right? So let's say slave 1, okay? I don't want to show this. Let me open it in Word. Okay, so you have to say it like this. So slave 1, 5, okay, double 5, slave 2, 5, slave 3, right? What happens is if your slave 1 is failing, if it is down, not in the mid, at the start it means that slave 1 is down, we'll go and run it in slave 2 automatically because you've given multiple options, right?
Not always that we can provide that infrastructure in our operations. Do we have any cloud services for this?
CloudBees provides it, so you could check CloudBees, but they charge you in dollars. I don't know, but it's pretty good tool. CloudBees is an enterprise.
So for a medium-sized project, what would be considered like?
I wouldn't recommend anything specific. I mean, it depends on your code. I mean, first of all, your code, how long your build runs, and how many parallel executions that needs to happen. Right? Let's say your main branch is you are working on a maintenance. You have a large team. One is working on maintenance release, the other one is working on a next release, which obviously means you need multiple parallels to happen on maintenance release as well as the production releases, right? Okay. Any other questions?
In pipeline, so I have been using Jenkins quite some time back, or other tools. One challenge that I had, I don't know, this plugin, the same plugin. One challenge was, let's say there are 10 versions of the code base. And imagine there are those 10 builds for each of those check-ins. So if you want to trigger, let's say version 8, the pipeline, and I want to deploy it to QA, the challenge I faced long back was it would always pick up the latest version only.
Yeah, because
is it still like that, or is it?
So you do not have an option to build that particular previous version. So that's still there. But you could rebase. I mean, you could revert your code back to that particular version, and or you could check out that particular version to do the build.
Yeah, but that's not practical, right? So the challenge I faced was, I'll give an example, right? So let's say you have got multiple commits, but the QAs would want to deploy a particular version for whatever reasons, right? But that's just impossible because the moment you trigger, it always picks the latest one.
But what we do is every build, when you do a sanity testing, a smart build, right? So you get multiple builds, right? You have it in your servers. So when QA wants it, they will only pick that particular one. The rest of the stuff will automatically get deleted in Firework. Whatever QA has to pick it, we have a dashboard interconnected. So they just have to mark it in that dashboard saying, hey, I want this build to be tested, right? Or they test it and see that the build is good, right? So they mark it in the dashboard. Automatically, we have we use Kibana dashboard stuff. So the entire data is in Elastic. So and our logic looks at what is in the database to see which build is marked or which one is not marked. Whatever is not marked, like if it is older than 7 days, we just don't remove from our server. So we save space at the same time. We build everything.
So what you're saying is, so the way we solved it that time was, let's say, like I said, there are 10 builds. The QAs want the 8th version. So that particular artifact that came out of it, when we had our own scripting or some scripting that was done to publish that somewhere else, and that would get picked up in the next step. So if you think about a pipeline, right? So there is some maybe compilation, unit testing, integration testing, bunch of things. Then QAs it gets deployed to QA environment. So QAs want to deploy, let's say, version 8. pipeline was not automatically doing it. The moment if you ask pipeline to pick it up, it was always picking up the latest artifact. So we had to do some manual delivery to get that done.
But if you have, like I was saying, if you have your bills in an artifact or in somewhere, you could have a separate job. Whenever you want to deploy it, you just have to, with a parameter, you need to have a parameter job where it says, just go and put it in the parameter saying,
Yeah, but
I want
they had to manually specify the parameter.
parameter. So to deploy it in queue.
That kind of shortcut is still there.
Yes, that's still there. And I think ThoughtWorks also have a CI tool, ThoughtWorks skill.
It was easy.
So it's a very popular tool as well. I was surprised that GeekNight they invited because they didn't talk about ThoughtWorks and they talked about Jenkins. They love Jenkins.
It's a community thing, so.
Okay. All right. Anything else? Any questions? Okay. Then I call it. Thank you.